Imagine an object so dense that a single teaspoon of its material would weigh over 1 billion tons. Hard to wrap your mind around, right? Well, that's the reality of neutron stars. These cosmic wonders are some of the densest, most extreme objects in the entire universe. But what actually makes them so unique? And how can something the size of a city pack in more mass than the sun itself? In this video, we're diving deep into the world of neutron stars. From how they're formed in the explosive death throes of massive stars to their mind-bending gravity and magnetic fields that push the limits of physics as we know it. So stick around, because you're about to explore one of the universe's most fascinating mysteries. To understand neutron stars, we first need to look at how they're born. These incredible objects are the remnants of massive stars, stars that are at least 8 times the mass of our sun. When a star of this size reaches the end of its life, it goes out with a bang in a supernova explosion. The outer layers of the star are blasted out into space, while the core collapses under the immense force of its own gravity. But here's where it gets interesting. Under this intense pressure, protons and electrons in the core are squeezed together, forming neutrons. The result? A core made almost entirely of densely packed neutrons, which we call a neutron star. Unlike white dwarfs, which are the remains of smaller stars, or black holes, which form from even larger stellar remnants, neutron stars are something uniquely strange. A balance between collapse and a force known as neutron degeneracy pressure, which keeps them from shrinking further. So just how dense is a neutron star? Picture this. A neutron star can have a mass up to twice that of the sun, yet it's compressed into a sphere only about 20 kilometers or roughly 12 miles across. To give you an idea, imagine cramming the entire mass of Mount Everest into a sugar cube. That's the kind of density we're talking about here. But it's not just about density. Neutron stars have insanely powerful gravity, which warps space and time around them. If you could stand on the surface of a neutron star, which, by the way, would be impossible because you'd be crushed instantly, you would weigh billions of times more than you do on Earth. The gravitational pull is so strong that if light were to travel near a neutron star, it would bend noticeably. In fact, the gravity is nearly strong enough to create a black hole. But unlike black holes, neutron stars exist at that delicate threshold where they're dense enough to be almost incomprehensible, but not quite dense enough to become black holes. Neutron stars aren't all the same, and there are 2 especially fascinating types: pulsars and magnetars. Pulsars are neutron stars that spin at incredibly high speeds, emitting beams of radiation from their magnetic poles. When these beams sweep across Earth, they appear to pulse, which is why we call them pulsars. Some pulsars can spin hundreds of times per second, faster than a kitchen blender. Then we have magnetars, the rare superstars of the neutron star world. These neutron stars have magnetic fields that are trillions of times stronger than Earth's magnetic field. To put that in perspective, if a magnetar were within 1,000 kilometers of us, its magnetic field would erase the data on every credit card on Earth. The magnetic power of magnetars is so intense that it can even distort the atomic structure of matter around them. Neutron stars aren't just fascinating in themselves. They're also key players in advancing astrophysics. Because they are so dense, neutron stars have provided scientists with a kind of natural laboratory to study the behavior of matter under extreme conditions. Unlike anything we can replicate on Earth, one of the most exciting discoveries involving neutron stars happened recently with gravitational wave detectors. When 2 neutron stars collide, they create ripples in space-time known as gravitational waves, which scientists can now detect. These collisions, called kilonovae, also produce some of the heaviest elements in the universe, including gold and platinum. So every piece of gold on Earth likely has its origins in a cosmic event involving neutron stars. Moreover, studying neutron stars helps scientists probe the very limits of our theories of physics, from the behavior of subatomic particles to the nature of gravity itself, allowing us to deepen our understanding of the universe. Let's dive into some fun and mind-blowing facts about neutron stars. First off, neutron stars can rotate extremely fast. Some spin as quickly as 700 times per second. This high-speed rotation is a result of the conservation of angular momentum as the original star collapses. Then there's the fact that neutron stars have starquakes. Because of the intense gravitational and magnetic forces, the crust of a neutron star occasionally cracks in what we call a starquake. This can release enormous bursts of energy, and some scientists think starquakes are behind certain high-energy phenomena we detect in space. And finally, there's the Crab Pulsar, one of the most famous neutron stars located in the Crab Nebula. It was formed from a supernova explosion observed on Earth in 1054 AD. This pulsar spins about 30 times per second, emitting beams of radiation that can still be detected here on Earth almost 1,000 years later. So there you have it, neutron stars, some of the universe's densest and most mysterious objects. From their explosive beginnings in supernovae to their incredible gravity and extreme magnetic fields, these stars challenge our understanding of what matter can become. What fascinates you most about neutron stars? Let us know in the comments below. And if you enjoyed this cosmic journey, don't forget to like, subscribe, and hit the notification bell for more deep dives into the wonders of space. Thanks for watching, and keep exploring the universe with us.